This meeting is being recorded.
Good afternoon, everybody. This is Brad Bradshaw with the Hydrogen Energy Center and the consultancy Valerity. Welcome to this afternoon's on East Coast time hydrogen session number 11 on hydrogen hubs, focused on the United States hydrogen hub opportunities associated with the Department of Energy. This afternoon, I will be providing a presentation that will be available online in a few days, as well as a web recording of this meeting. And I will be assisted this afternoon by Rick Smith, who is founder of the Hydrogen Energy Center. And, we will be taking questions and answers at the end of the presentation session. So please make note of any questions you might have during the presentation. Rick, are you online today?
I am here, Brad. Thank you.
Yep.
Where should the questions be put? In the chat section?
Yes, chat has been a fabulous resource because it allows us to capture the questions and
Right.
and people to enter them. So thank you for that suggestion, Rick. Also, if people can keep their microphones on mute during the session, that would be advantageous, and we can always you can always unclick the mute button to speak when appropriate. So Rick, I'll ask for your assistance. Can you see this presentation?
Yes, I can.
Okay.
Full screen on my screen.
Oh, good. So unless there's anything else, Rick, I think we can get started.
I think you're right.
Okay. In terms of time frame this afternoon, I think what we'll try to get the bulk of the presentation done within the hour, but we've added another 15 minutes for the Q&A just to make sure that there's full coverage. So we appreciate your participation throughout. Now, if I can get the navigation correct. So today's agenda is focused on the DOE upcoming FOA, which is the funding opportunity announcement that is expected to take place in September or October this year, associated with the $8 billion allocated to what the DOE terms regional hydrogen hubs. So we're going to spend a certain amount of time reviewing the DOE Hydrogen Hubs initiative. We also have the opportunity, given recent activity in the federal level, on the information on the Inflation Reduction Act of 2022. I understand that that should be signed today. So it's clearly a very current piece of legislation that has a significant impact. And it has very strong incentives up to a max of $3 per kilogram for hydrogen production. We also will present information this afternoon on the hydrogen hubs globally around the world taking place. What we've done is identify the top 30 hydrogen hubs in the world. We will then take a deeper dive on the United States hydrogen hubs that have been in development or in construction, or in some cases in operation. And we will look at then the consortia that have formed around the hydrogen hub opportunity in the United States. There are, on current estimates, 24 hydrogen hub consortia that are interested in this, in applying for this Department of Energy opportunity. I suspect there will be some winnowing out and some agglomeration that will take place. And we'll close today with summary and perspectives and question and answer. I've provided some background on myself in terms of work that I've done and place I've been. You can review this on your own. Currently, I am president of the Hydrogen Energy Center, a nonprofit organization that has done work projects in hydrogen and conducted forums in hydrogen for more than 20 years in terms of seeing hydrogen as a central element to the renewable energy future. And I also am president of Larity, a consulting firm that provides management consulting. We have done a lot of work in the hydrogen area in the past year and a half. It's been a very active market. HEC has been active in promoting hydrogen as a key element to a renewable energy future. It is available for membership, and we encourage you to join. We provide public forums. We conducted research recently with the Connecticut Center for Advanced Technology in the area of looking at early market opportunities for hydrogen. 15 years ago, HEC implemented a hydrogen-based backup power system for an animal rescue center in Maine, used high pressure electrolysis to generate hydrogen from solar energy. It compressed and stored that hydrogen and then used it for generating electricity for backup power using several fuel cells. So it was very innovative at its time, early stage project. Just one example of some of the work HEC has done over the years. Some of the projects that Valerity has done, we've been working with a number of hydrogen companies and looking at the opportunities We've looked at the acquisition opportunity for a solid oxide fuel cell company, for example, within the past 18 months. We did a hydrogen entry strategy for a $7 billion global materials manufacturer that is seeing hydrogen as a significant business opportunity to enter. One of the projects I enjoyed last year was looking at green hydrogen and the role in mitigating carbon emissions for a wastewater treatment facility, producing synthetic methane and synthetic methanol, capturing CO2 from a boiler stack and using green hydrogen to synthesize methane and methanol as a means to mitigate carbon emissions at a wastewater treatment facility. It's really a groundbreaking piece of work. And we've also, one of the areas which is central to today's discussion is the green ammonia market. I was brought on as a member of a team for a global consultancy to assess the green ammonia market and the business strategy therein. Ammonia is responsible for a significant amount of greenhouse gas emissions globally, so there is a decarbonization role for green hydrogen in ammonia production. But ammonia is also seen as a potential fuel. Japan has identified ammonia as a feedstock for cutting carbon emissions with coal-fired power plants. And there will be some significant legislation globally next year on using ammonia for propelling ships globally as a zero carbon fuel for the shipping industry. So we will see a growth in the demand for ammonia in a decarbonized future, not just the decarbonization of existing demand for ammonia, but new ammonia markets emerging. And I did just want to posit this thought at the beginning of today's presentation to remind ourselves as to why the hydrogen revolution is taking place. There are many drivers, but fundamentally, the unbelievable reduction in the price of power from solar energy globally in the past 10 years is really a fundamental shift in energy markets. And this is an enabling transition that allows hydrogen to be competitive with existing fossil fuels and solutions, clearly depending on the markets, the applications, and other factors. But I do want to point out that Saudi Arabia has seen PPAs in the 1.2 cent range. We also are seeing that level in India, and Portugal, remarkably, is becoming a major hydrogen hub because they have had a very aggressive strategy associated with solar deployment in Portugal. And Portugal is really going to be a real powerhouse in this industry going forward. And fundamentally, the PPA pricing for solar is a key factor. And we will touch on this later, but there is a massive geopolitical shift taking place in the centers of energy production around the world. And we're going to see places that we don't expect at first, but Africa is emerging as a key player in this market. They're lagging, certainly on the global stage, but you will see in the next few years massive investment opportunities emerge in Africa, for example. We are also seeing Australia very aggressively pursuing the export market associated with hydrogen, and massive investments. I think Australia is probably over $150 billion of committed capital to hydrogen hubs currently. The context of the DOE program, I just want to address that briefly. They developed these shot programs, energy shots, and hydrogen shot was introduced on June 7, 2021. They have the carbon negative shot was introduced on November 5th last year, and then the long duration storage shot was introduced on July 14th last year, just over a year ago. And on this timeline, we also see the Infrastructure Investment and Jobs Act was signed on November 15th of last year, and that includes specific language that has fed into this FOA for the regional hydrogen hubs. And we also see the more recent Inflation Reduction Act of 2022, presumably signed into law today, but very surprising and aggressive, roughly $350 billion initiative that includes significant programmatic incentives for green hydrogen production. The Hydrogen Shot Initiative has as its crowning objective the 1-1-1 strategy, they refer to it. So it's $1 per 1 kilogram in 1 decade. So $1 a kilogram in 10 years. And there's a range of factors clearly which influence achieving that. And the view is that it's now 5 times higher. In other words, that the current price for hydrogen in the clean hydrogen world is about $5 a kilogram from a production point of view. So the objective is to reduce that by 80% going forward. And certainly that's a combination of improvements on electrolyzer capital cost, electrolyzer efficiency, but also clearly the sourcing of renewable energy in order to achieve that dollar figure. So this sets up the context for where this regional hydrogen hubs initiative is coming from, and the Department of Energy sees that hydrogen has a key role within the context of achieving greenhouse gas reductions, more equitable environmental and economic future, and as well as keeping along the energy independence routine in the United States. So the timeline of the regional hydrogen hubs up to now, because the timeline going forward, you'll see in a minute, is somewhat complex or contorted. First, we saw the Infrastructure Investment and Jobs Act in November 15 last year. Then the request for information was issued on February 15. The DOE received about 300 responses to that request for information. They certainly set themselves up for a lot of work and effort in order to turn around those responses. And the notice of intent was issued on June 6th, which is really, I guess, the warning bell, that the FOA is coming. And then finally, we will see, or are expecting to see, in September or October this year, the actual funding opportunity announcement. And we'll talk about what that really is going forward, because they're actually looking for sort of concept papers initially before the full applications are due. And they are going to try to do some winnowing pre-selection before they get to the full FOA applications. So the DOE was allocated $62 billion with the Infrastructure Investment and Jobs Act, including $8 billion over a 5-year period. And it is important to note that the Hydrogen Hubs program is a staged multi-year program, and the $8 billion is just for the first 5-year period. And I presume that there will be subsequent allocations of capital from the DOE for the subsequent phases on a going forward basis. And the Congress has set up very specific criteria for the program, but they also allow a certain amount of latitude for the Department of Energy. So it's a minimum of 4 hubs. The view is that they might select upwards of 10 hubs initially, which may help in terms of the competitive intensity of the program, which we'll talk about a little bit later. And again, they are trying to accelerate the development of large-scale hydrogen production facilities in order to drive costs down. And fundamentally, the core here is the assumption, or the implicit sort of assumption, that scale will help drive cost down, and that setting up these regional hydrogen hubs, which include source all the way to use, will help create an energy web that advances hydrogen as becoming part of our energy future. I'll touch on it a little bit later, but it is interesting to see that nowhere in the legislation is mentioned from a criteria on evaluation or selection of projects is the cost of hydrogen. Kind of an interesting omission, and we'll see what happens with the actual FOA on that score. The RFI, as mentioned before, was issued February 15. And again, they really wanted to get feedback in terms of how to structure the coming FOA from a range of perspectives. And there was a lot of questions on the RFI on, what is the definition of regional, and what is the definition? I mean, it's just a lot of definitional factors going forward. So the notice of intent was issued in June, and that the first stage, as mentioned earlier, will be the issuance, the preparation of concept papers or project summaries that will be submitted within 6 to 8 weeks of the FOA. And then the DOE would like to provide feedback on those concept papers to try to winnow the field and say, well, you might not be responsive, don't waste your time, etc. And so there will be a competitive consideration going forward. I'm sure anybody will be able to apply nonetheless, regardless of their feedback. Now, the criteria that they've issued is somewhat interesting, and I'll go over the criteria of the program for the hydrogen hubs, and we'll talk about it a little bit later. And I sometimes think of these criteria, these initial criteria, as so-called binary criteria, almost like a checklist. It's sort of like the in-out kind of concept. Either you've got the check next to your box, or you don't on these criteria. So feedstock diversity, and we'll also see that some of these criteria are a lot more important or impactful potentially than other criteria. So feedstock diversity, at least one hub shall demonstrate production of clean hydrogen from fossil fuels, one hub from renewable energy, and one hub from nuclear energy. This criteria is really not a concern. I think the one criteria here that will be a potential differentiator is nuclear energy, but renewable energy should be part of almost every single application. Fossil fuel might be kind of a limited, and we'll see that it might be limited for just the fact that it might not be as competitive. From a cost perspective, it might be more difficult to set up a commercial hydrogen hub with fossil fuels and CCUS or sequestration. But we certainly will see, for example, the West Virginia, Ohio, Pennsylvania hub is focused on natural gas-based hydrogen production with sequestration and using that hydrogen for power production. So we will see also we will see some of these in Louisiana and Texas, certainly. And I think that those three locations will basically take the cake on the fossil-based hydrogen production. We may see something out of the petroleum industry in California as well on this score. But
Brad, if I could chime in for a second.
Please, Rick.
The Department of Energy's fossil department has recently issued about a dozen grants, and there are some carbon sequestration awards, but the vast majority are in the solid oxide fuel cell or solid oxide electrolyzer side of the house. So it may be that someone at DOE is thinking about using fossil fuels in a solid oxide fuel cell.
Okay, good. The second criteria that is listed is end use diversity, and they're looking at the hydrogen in power generation, hydrogen in the industrial sector, at least one hub in the residential commercial heating sector, and one in the transportation sector. And strangely, the one that is least likely to be included by people, but probably one of the easiest to satisfy, might be transportation. It's a little bit tricky because that's more of a regional application, smaller demand, and you might need a liquefaction solution there. So it's sort of an oddball relative to major hydrogen hubs. The industrial sector is going to be end use specific in terms of feeding. The res and commercial heating sector solution is fairly straightforward. We'll certainly see some hydrogen injection into natural gas pipelines, and that pretty much satisfies that requirement. So the end use diversity and electric power generation, we already see a number of hubs that are doing that, a small number, but a select number of hubs that are doing the power generation. I mean, certainly the Delta Utah project, the ACES program, that is a huge energy arbitrage strategy that uses hydrogen storage coupled with natural gas turbines. And the hydrogen will be running the arbitrage opportunity between sourcing inexpensive hydrogen from renewable energy, storing it for long periods of time at high volume, and then running it back through turbines to generate electricity in order to capture the maximum arbitrage opportunity from that as well. We'll talk about a little bit of that. The geographic diversity is really just to make sure that this is a distributed program from a geographic perspective in terms of the money going out. Hubs in natural gas producing regions. Now, this is really the most impactful, really, of the criteria so far. And the reason is that there are really only 2 natural gas producing regions in the United States. And if we allocate those 2 regions to a hub, and they go for the minimum of 4 hubs, that leaves the whole rest of the country to compete over 2 hub slots. So that locks out a lot of people with respect to the criteria. Certainly, Texas is in the lead. The whole Texas, Oklahoma, Louisiana area is one of the natural gas producing regions. And the other one is Pennsylvania. And the whole sort of Ohio, West Virginia, Pennsylvania region is the other plug and play for being a natural gas producing region. So we will certainly see, very likely see, a hub come out of that West Virginia, Pennsylvania, Ohio region, and another hub come out of basically the Texas, Oklahoma, Louisiana region. And then the whole rest of the country will be competing for the 2 remaining hub slots, if the minimum is 4, depending on the phase of the program and the winnowing as it goes forward. And then finally, the employment criteria, skilled training, long-term employment, the greatest number of residents that can be employed within a region. And so there is going to be some fine pencil work on what that is. And again, that feeds back into scale. If you're going to have large solar, large wind, and a large system deployment, you're going to see a lot of employment opportunities emerge. If you're just doing a single facility, which is a natural gas ATR with carbon capture and sequestration, there may be less of an impact from an employment perspective. So again, you can see there'll be a natural drive towards integrating renewable energy solution into a regional strategy that'll help increase the greatest number of residents that are employed in the project. Additional metrics, and these may be termed additional metrics, but they are important metrics. One is preference given to applications that reduce greenhouse gas emissions across the full project life cycle. Now, it is very interesting to note that the DOE has yet to promulgate the basis by which they will calculate greenhouse gas emissions for project proposals. And that's important. For example, which scope of emissions are included or excluded from this program. For example, there's been a lot of analysis and discussion on upstream emissions associated with natural gas infrastructure. And it can be calculated that the emissions upstream of a ATR, pyrolysis, or standard SMR system can have a rather large impact on greenhouse gas emissions. And that would certainly impact how a project scores on this particular metric. Again, this metric will then favor the deployment of the renewable energy strategies as opposed to the fossil-based strategies as we go forward. And certainly don't forget the nuclear would certainly have an advantage on this score significantly as well, and place nuclear and renewable energy in a leading position, depending on how much importance the Department of Energy places on this particular criteria. Preference given to hydrogen hubs that produce larger quantities of clean hydrogen. This relates to the concept of scale will drive out cost, and scale also will create sort of a leveraged market opportunities going forward. And this is embedded in DOE's thinking, which is the importance of scale to help enable hydrogen as being an integral and competitive solution in the economy as we go forward. So it's important to look. There are some individual hydrogen hubs that are listing themselves as potential applicants in the process. We do see that there is going to likely be some aggregation of some of these individual hubs into regional, hubs greater than individual states. I think the individual states that will remain as competitive players in this, certainly Texas is one, and California is the other, mostly because of the scale in California and the aggressiveness in California on renewable energy development is advantageous. And Texas certainly has a lot of factors that are favorable: great wind, great solar, great infrastructure, a great experience with pipelines and siting and construction of these types of systems. Not to mention also that they have significant sequestration opportunities, as well as they're linked into the Louisiana-Texas hydrogen pipeline, which is advantageous as well. And certainly the issues associated with energy and environmental justice are important. It's very interesting that they put in criteria around the community engagement and consent-based siting as well as important metrics going forward. The going forward timeline for the regional hydrogen hubs. This is let me just sort of go through this. The FOA is expected to be released September and October. Concept papers, I've seen different estimates, but basically 4 to 6 weeks, maybe even 8 weeks after the FOA is released. Then there'll be another period which the DOE will review these concept papers, and then there will be a notification that the full application will have its specific due date. And so we can see full applications in this particular case are likely due in April or May in 2023. So this sort of sets the timeline in terms of full applications for this initial regional hydrogen hub FOA. Then we can see a series of phased awards. So phase 1, we can see the awards in the June-July timeframe 2023. And then there will be subsequent funding going forward, phase 2, phase 3, and phase 4. And we'll likely see greater clarification on those initiatives, but it basically is the Hydrogen Hub initiative has a going kind of activity associated with it. The first awards could be 6 to 10 hubs, as you can see here, and there will be an expected winnowing of the number of hubs that are supported on a going forward basis. I did want to just point out some of the location-based information with respect to the binary criteria. So, for example, California, they only have 1 nuclear power plant. So if they want nuclear in their program, it has to be that one. You can see there is a Colorado-based regional initiative. There are no nuclear power plants, so they can't include it in their application. And the Northwest has 1, is looking at an Oregon-Washington consortium. They have 1 nuclear power plant, so if they want to include it, it has to be that one. And there will be concerns about the scale and the allocation of the amount of power that the nuclear plant will allocate to these programs. Because frankly, it's very likely that nuclear plants will make more money selling in the wholesale markets with special agreements and so on than they will selling into the hydrogen program, but that will vary significantly by region. And the PUCs in different states might have more favorable nuclear policies that change the economics and the likelihood of nuclear participation. You can see that, you know, basically east of the Mississippi and up in the central up towards Chicago, there are a lot more in terms of nuclear plants to choose from in terms of having them join on to the consortia opportunity. I apologize in advance for the complexity of this chart, but it is very comprehensive because it shows major CO2 sources in the country, which would be power plants of which CO2 emissions could be abated or mitigated. But it also shows potential geological storage. And so the issue of sequestration, an awful lot of work has been done on sequestration, and there are these regional sequestration partnerships amongst states and within states to pursue this area. And basically, it's I wouldn't say it's settled science, and in fact, I'm not an expert on the geologic considerations of sequestration, but there are many locations in the United States in which you can drive high-pressure CO2 down about a mile, and the whole idea being that there has to be a layer above that, which is an impermeable layer for CO2, and that's basically the strategy. There are different geologic formations in which there would be different strategies. There is a cost associated with sequestration. Dominant cost, of course, is the actual carbon capture from a flue stack, and so that's a key consideration in the current phasing of technology development associated with carbon capture and sequestration. sequestration can be as low as $50 a ton. Basically, the capturing part can be anywhere from $200 to $400 to $600 a ton. I mean, it's very expensive and fairly uncertain at this stage in terms of getting that cost down. But a lot of effort is being made in that area. I spoke to this earlier, the criteria that 2 of the 4 hubs, or 2 hubs minimum, have to be in the areas of natural gas production. And you can clearly see that that would be centered on the Texas area and the Pennsylvania, West Virginia, Ohio area. And it's very likely that 2 hubs will be positioned in those 2 areas fairly clearly going forward. So that's not there's no no magic associated with this information. It's fairly straightforward. Okay, so those are the 3 charts. Thank you for that. Now, I did want to mention, and this, we had to come up to speed rather quickly on the Inflation Reduction Act of 2022. And I think the importance of this is significant. It's includes a hydrogen production tax credit, a PTC for hydrogen. As you know, there's a PTC that's been in place for wind for perhaps 20 years, and it's been very successful. And so here we see a similar type of incentive, and it's based on providing that dollar figure to producers of hydrogen over a 10-year period. So it really helps in terms of capitalizing and helping improve the economics of hydrogen production. It also is important just to note quickly that there are other incentives associated with hydrogen in this act. One is that hydrogen energy storage is defined within the energy storage provisions of the act. So there are incentives in ITC, investment tax credit, for energy storage, and hydrogen is specifically within that criteria. Second, they've introduced a substantial credit for clean commercial vehicles. And this is a key use case for hydrogen for heavy transport. And so that's an important development. I've seen some figures kicking around in the high tens of thousands of dollars per vehicle associated with this incentive. So it is important, an important incentive here. Finally, the development of fueling stations, and we do see that there is a credit which is geared towards hydrogen filling stations, which would be very helpful to have a mechanism which drives capital to reduce the initial cost of bringing up hydrogen fueling stations. The Section 45 of this, the production tax credit, there are some specifics associated with this, but in sort of the broad view, there's a range of incentive between 60 cents a kilogram and $3 a kilogram. And in this particular case, the criteria is based on carbon emissions, or CO2 equivalent emissions. And it's expressed as kilograms CO2 per kilogram of hydrogen produced. And we can see that the credit is marginal at the beginning, but it accelerates significantly when you get below, when you get below half a kilogram CO2 per kilogram of hydrogen. And the criteria for clean hydrogen on the investment infrastructure program is about 2 kilograms CO2 per kilogram of hydrogen is considered clean hydrogen. So this actually tightens down quite a bit from that clean hydrogen criteria. This is a very significant opportunity and going forward. Other factors, this first one is important. If you're doing CCUS, if you're doing carbon capture and sequestration, and you claim the 45Q tax credit for CCUS, you cannot claim the hydrogen production tax credit in this program. So there's no overlap with respect to CCUS. So that's important to consider. Also note that they include the opportunity for people to switch out an ITC credit for PTC, certainly. And they also include the ability of transferability, which has been a real boon, been great in the solar field, because you can take your solar facility and obtain financing that someone else has a tax liability that they could use in advantage. So that's very important. And the dollar figure associated with this, $13 billion over the next 10 years. So fairly significant incentive for hydrogen. We're really going to see things move along now. I do want to spend a moment on a few other areas, try to zoom through some of this, but identified 30 of the largest hydrogen hub projects around the world. And I do want to take a moment just to make it clear on definitions that there are around the world what are called green hydrogen projects, electrolyzers producing green hydrogen, etc. And then you move up from that, the larger projects could be considered hydrogen hubs. And these are examples of that. They're sort of in the range up to about 500,000 tons of hydrogen produced per year and up from that. And then the other definitional consideration is the hydrogen hub consortia in the regional hydrogen hub initiative from the DOE. There are hydrogen hubs, but they aren't necessarily hydrogen hub consortia or regional hydrogen hubs. We've actually seen regional hydrogen hubs form without any physical infrastructure existing or planned, which is kind of forward thinking on the part of politicians and legislators and so on. So it's important to recognize some of the definitional considerations as we go forward. It's important to note where these hydrogen hubs are. Australia, in this particular capture, has 6 hydrogen hubs. Between Oman and Saudi Arabia, there are 3 hydrogen hubs, and those are major. Brazil has come into the picture. They have 2 hydrogen hubs in Brazil, and one of them is the biggest hydrogen hub program in the world, which is fairly significant as well. So, and then we can see up in Europe, in Northern Europe, there's a cluster of hydrogen hubs, and I think there's about 5 of them up there. Those are, I think, pretty much all taking offshore wind power and converting it to hydrogen and proceeding on that basis. Well, not all, I will take that back. There is the LEADS 21 program, which includes ATR and SMR hydrogen production, as well as some offshore wind complementing it as well. So that includes fossil-based solutions as well. The hydrogen production of those 30 facilities is about 53 million tons per year, which is quite significant. I think the global production of hydrogen today is about 80 million tons per year. So you can see already on the books for these 30 large facilities represents 2/3 of the existing hydrogen production market. So talk about scale. And if you look at it going forward, it may seem to be a lot, but if you look at some of the conversion strategies for places like Japan and some of these other applications in terms of end uses, we're going to see a significant increase in demand for hydrogen and residual products on a going forward basis. The bulk of the hydrogen is produced, as you can see here, nearly 90% is from renewable energy, 2% from petroleum, and 9% from natural gas. So basically, we're seeing about a 10% natural gas. The petroleum is a single project that Shell has put in Holland, in the Netherlands, that is recovering residual petroleum from a petroleum processing plant and gasifying it. So it's a fairly unique solution in that case. Average size of these projects, the 30 projects, overall, you can see it's close to 2 million tons per year of hydrogen production, and the natural gas is about half the size of that. Typical natural gas with ATR, SMR is about 1 million tons per year. Good sized projects nonetheless. I'm going to provide just 2 examples of projects so you can get a sense of what we're talking about here. This is a $36 billion project, fully commercial. When I say fully commercial, it's a commercial project. In other words, it's standing on private investment legs at this point. BP just came in on this project, I'd say about a month ago, and developed by Intercontinental Energy, which is a brilliant company. They're looking at developing 26 gigawatts of combined solar and wind, and pumping that into about 14 gigawatts of electrolyzer, and again, producing close to 2.5 million tons per year of hydrogen. And they'll convert that into ammonia and ship that ammonia to markets around the world on a going forward basis. And the project, this one I think is in northwestern Australia. This project and the importance of that, the solar and wind are behind the fence, fully part of the project. There's no grid interconnection. In other words, it's behind the fence or behind the meter in the fence kind of strategy, and dedicated wind and solar facilities. A massive, if we look at the amount of land required, over 6,000 square miles associated with this project. So we can see the scale of this is just extraordinary. Another project I wanted to bring up, which is really fascinating, which is, we've seen a bit of a pattern, which is the offshore wind to hydrogen. And in this particular case, they're actually going to locate the electrolyzers offshore, and they're going to pipe the hydrogen in through pipe along the ocean floor. And they do have an island, which is a German island, which is going to be that central dot in the middle of the image. And then the hydrogen will go on further to land, and then be integrated in a pipeline system. And this is important. We see, most hydrogen is consumed in the place it's produced, because it's very hard to transport hydrogen. And we can see most of these projects are converting hydrogen to ammonia and transporting ammonia. There are 2 LOHC liquid organic carrier programs, liquid hydrogen organic carrier programs in place, but mostly we're going to see ammonia production as well. The pipeline strategy here is that the offshore wind will be converted to hydrogen, and then the hydrogen will be piped into the natural gas pipelines that are either blended or dedicated. And in this particular case, it's likely they'll be dedicated and fed into industrial feedstock applications for hydrogen. The cost of laying a electric cable versus the cost of laying a hydrogen pipe, it's massively less expensive to transport hydrogen. If they just transported the electricity to shore and then converted it to hydrogen, that's a lot more expensive. They figured that out, so they're going to be locating electrolytic solutions as far up the value chain as they can, and using pipelines to transport hydrogen as opposed to laying undersea cable for electricity transmission. The United States is maybe in some cases behind the world, but maybe that's not a fair assessment. There are some very good projects that are underway in the United States. We can see here one that gets a lot of press is the ACES program, the Intermountain Power Project in Delta, Utah, that is associated with feeding the LADWP system in a way to take an existing, I think it's like a 926 megawatt coal-fired power plant and converting it to natural gas and then converting it to hydrogen to decarbonize the power. It's integrated with a massive underground storage of hydrogen and then running turbines. And again, this is the energy arbitrage opportunity. The Great Plains Hydrogen Hub, that was a big coal synfuel project that basically failed or doesn't make sense anymore. And it's being converted to an ATR solution with natural gas and carbon capture, the Great Plains Hydrogen Hub. And perhaps you all have heard of Monolith, which just raised, I think, $1 billion from the Department of Energy. They originally were going to feed hydrogen into the power systems to produce electricity within the region. That didn't seem to be the right thing to do, so they've quickly migrated to an ammonia-based system to produce fertilizer for the fertilizer market, and they're heavily in the Corn Belt, and it's a clear choice, a good choice to make. And certainly with ammonia going from about $600 a ton to I think close to $1,800 a ton right now, there's certainly an economic case to be made for producing fertilizer with renewable energy, which could be cheaper, could be down around $1,200 a ton, for example, as well. So that's innovative. That's pyrolytic methane pyrolysis, turning natural gas into elemental carbon and hydrogen. Very unique. Aren't seeing a lot of that, but I think that we will see a lot more of that going forward. Air Products, their Burnside program in Louisiana, they're looking at, again, a lot of infrastructure there around natural gas and certainly pipelines and the ability to sequester carbon. So they're pursuing natural gas reformation with carbon capture and sequestration, and so on and so forth. I think the ones that are interesting in the Texas, Oklahoma, is the Hydrogen City, Texas, is a massive wind and solar initiative, turning it into ammonia and exporting ammonia. And the Woodside Ardmore, again, another massive renewable energy initiative. And I think we're going to see a lot more of those types of hubs as we go forward. I think the reason I think that the U.S. is kind of behind is that we only have a couple of those renewable energy programs for hydrogen production. And I think we're going to see a real growth in that south central part of the United States in renewable energy dedicated to hydrogen and ammonia production as we go forward. The dominant business models, the global hydrogen trade with ammonia is dominant. It's important to note that those projects that we identified, the global production of ammonia is about 180 million tons a year. Only 10% of that, about 18 million tons a year, is traded. And in the quantity of ammonia that's going to emerge from the existing suite of projects is going to be 5 times that level. But that's supported because there are markets in Japan and elsewhere for that decarbonized ammonia. The second is industrial process decarbonization. We can see steel mills in Europe are looking to use hydrogen instead of their standard coking process. And we're also seeing an move towards value-added products, the residual products like synthetic methanol, as well as the sustainable aviation fuels as important value-added products for hydrogen production. Briefly, key drivers, certainly the supply, the low cost of photovoltaics and other renewable energy. The increasing penetration of renewable energy creates a problem on the grids, that there'll be periods where there's way too much renewable energy, not enough demand, and that creates longer and longer periods of low price regimes for electricity that these hydrogen systems can leverage. We also are seeing on the demand side the sector-wide decarbonization occurring. For example, New York has pushed legislation forward for sector-wide decarbonization, and there's certainly in Europe much more of a recognition of the importance of using hydrogen in the hard-to-abate sectors. What are the key success factors for hydrogen hubs? Low-cost sourcing. That's the biggest one. Low-cost renewable energy, behind the meter, in the fence, renewable energy. Demand, figuring out the productization of hydrogen and where that product is going to go. Securing the associated off-taker agreements for that. Integrated strategy means you have to look at the whole program. You know, there's not going to be a strategy where you just produce hydrogen for a market. You really have to productize that hydrogen and identify exactly where it's going to go and who's going to pay for it and how much they're going to pay for it. It's worthy of a whole nother webinar, which is the economics of the end uses of hydrogen, and they range widely. Displacing natural gas with hydrogen is $5 an MMBTU is not a real going concern. But if you're displacing diesel at $28 an MMBTU, there's much more of a play for hydrogen in that market. And that just provides an illustration that not all end uses provide the same amount of dollar value per kilogram of hydrogen, and that's very important. Capacity factor, if you're putting in liquefaction, if you're putting in an air separation unit for nitrogen production, if you're putting in a Haber-Bosch process to produce ammonia, you're going to want to keep that equipment operating. And so we're seeing overlaid programs where you're either putting in solar plus storage, or you're solar plus electric storage, or you're putting in solar plus wind, and you're really focused on trying to get the capacity factor up in order to get good utilization of your capital equipment. And that's an important consideration. Wind is much more favorable capacity utilization factors than solar, but solar is delivering a much better price than wind. So, you need to balance those two in the economic models. And then finally, again, most hydrogen is used where it's produced. You have to minimize transportation. We're seeing a lot of programs in Europe geared towards pipelines. We're seeing a lot of programs in places like, the Brazil hubs, the Australia hubs. They're converting to ammonia, a few LOHC, productization, sustainable aviation fuels, methanol, for example. Those are strategies to facilitate eliminating the high cost of hydrogen transportation by converting it to something that's easier to work with. Just a couple more slides and we'll open for questions. The about 24 hub consortia have been identified, and I want to make it clear that, talk about a moving target. I mean, the last 12 months have been crazy in the hydrogen world in terms of the hydrogen hub announcements, these initiatives around the consortia, and it's very tricky. And most of these consortia are not hubs per se. Some are specifically hubs, some include hubs, most don't include any hydrogen hubs at this point, but are more ambition driven in terms of participating in the initiatives. We also see a lot of overlap. Ohio has a lot of consortia associated with that state, and presumably at some point we're going to see a consolidation. There have been calls. I think Colorado put out an RFP for or an RFI type call for hub development. In California is also open invitation for all comers to come in and propose their hub initiatives to be aggregated into the California hub initiative. So we will see some conglomeration going forward. I do want to just speak briefly to the major regional hydrogen hubs that have been identified. And I think there are some here that certainly have their challenges and others that have their advantages. Again, I think Texas is the winner. Texas is going to win in this game. They may join up. We can see that there is the Halo hydrogen hub, which is Oklahoma and Louisiana, and they have some real advantages as well. So that's going to be a very powerful area. The yellow, the Ohio River Valley, also known as the Upper Appalachian hydrogen hub, they're going to be in the program. They're very aggressive. Senator Manchin is spearheading this, I suspect, and we're going to see perhaps some success here. Will they have their challenges? Yes, they may not go to producing ammonia. They may just all do feedstock for power production, and that's a weak economic case for hydrogen, and that may hamstring the ability for them to develop a commercially viable project with complementary commercial funding as well. I think California is going to be strong. I think the Western Interstate Hydrogen Hub, the green in the lower left portion, they have significant renewable energy resources, and the question for them is going to be how they're going to move that product to market, and they're going to need a viable strategy around that solution. California has identified the pipelines, hydrogen pipelines, as being important. They'll be able to put significant renewable energy resources out in the open land, and then be able to feed the hydrogen into the cities in the metro areas in order to drive power production, transportation, industrial use, what have you. And I think that's a very smart strategy. The pipelines are the cheapest way to move hydrogen. The Northeast, where I'm located, they're going to have a very aggressive program, but I think it's going to be challenging, and we'll see how that goes. I mean, there's significant market demand, there's significant use of resources. I think the real ace in the Northeast is the same along the entire Atlantic coast, which is there's going to be 35 gigawatts of offshore wind developed, and there are going to be times when the grid is only calling for, say, 20 gigawatts of demand. There's going to be another 15 gigawatts of wind just spinning without any place to go. And I think that's going to be a real advantage for the hydrogen infrastructure strategy for the Northeast as we go forward. So finally, 2 closing slides, and then we'll open for questions. No question, hydrogen has a central role in the clean energy future. And we can see a range of applications that are emerging as the winners here. We are seeing a massive shift in the geopolitics of energy, and that's going to favor places with lots of open land, lots of solar insulation, and good wind resource. And the hydrogen hubs already see about $300 billion in commitment and capital around the world. And I think that anyone that's developing a hydrogen hub has to think big and think well beyond the DOE initiative. The DOE initiative is just very helpful to get the program going, maybe address some of the risks, and so on. And finally, I've mentioned this before, the natural gas producing regions are going to command a couple of hubs. Preference given to greenhouse gas emission reduction. That's going to be an important criteria to consider going forward. The scale is going to look at multi-state aggregations are going to be favorable, and large plants are going to be favorable. And that means, where are you going to find 1,000 square miles for wind and solar, for example? And I think that's going to be important to consider, which is where's the scale opportunity lie in this initiative going forward. So with that, I think we'll open it up for questions. Rick, are you identifying some questions that we can address?
The questions so far, Brad, have all been compliments on your presentation and requests that we make the information available, which I know you are going to do. So I think that's super, and I of course agree with those sentiments. If I can toss in a comment, not a question, but I have a comment on the relationship between one of the US hubs and one of the international hubs. The High Deal LA project is patterned on the High Deal Europe project in northern Spain. It was one of the dots on the international map that you showed. It's very close to the northern Portugal project. The High Deal Europe project started maybe 3 years ago, 3.5 years ago, and High Deal LA was only a year behind. High Deal LA deserves a shout out because they are going to bring pipeline, dedicated hydrogen pipelines into the LA basin and generate some electricity in the basin and make hydrogen and use a lot of the hydrogen in the port facilities, including encouraging clean shipping corridors. They're looking to start a container ship corridor where the container ships run on either clean hydrogen or clean ammonia or green ammonia. They are particularly good, and the primary reason I'm mentioning them, they have been particularly good in engaging civic groups and community groups. You noted the criteria for environmental justice and labor, and High Deal LA has been incredibly comprehensive in engaging the unions and workers of various types, several different neighborhood groups regarding where things will be located, and in general is providing a great model for that part of a project if someone is worried about how to go about doing that part of a project that might qualify for hydrogen hub funding from the DOE. The best place to get information on that project is from an organization called the Green Hydrogen Coalition, GHC, the Green Hydrogen Coalition. They've been coordinating a lot of the High Deal LA project.
Perfect. Yeah, I think California will have its challenges, so I think they're going to have to definitely perform on as many of the criteria as they can find. We will send an email out to all the people who registered for today's webinar that will include a link to the Hydrogen Energy Center's location where the presentation and the webinar are available.
A couple of questions have come in, Brad. One is, how could the appropriation process impact the outcomes? Take your political crystal ball out and see if you can answer that one.
Yeah, I think that's there may be. I'm not exactly sure. Usually, Congress doesn't like having future obligations from existing money. But they may have allocated a certain portion of the $65 billion in this initiative to some of the future phases, but I'm not aware of that. The appropriation process, it's the $8 billion is one and done from what I understand. There's no issues associated with the availability of that money. I think now it's off to the races in terms of the competition. And
another question is, how do the existing hydrogen hubs differ or fit into the DOE 8 billion hub initiative? I think part of the answer to that is that this $8 billion has been in the works for a very long time, and a lot of these groups formed themselves to be early on players in attempting to get their part of it.
Yeah, I think some of the hubs that are in the presentation are further along and won't participate because they won't need to participate. The back end, for example, they probably will try to participate. The North Dakota one, the Monolith and Intermountain Power, they probably won't. Monolith, I think, just raised $1 billion from the DOE, so they might be tapped out in that regard. And then the Intermountain, it's uncertain how they will play. They might try to scavenge some money, from the program as well. But we'll see. A number of the others are really just our announcements between parties at this point, and they certainly will participate. And I think, look to the Louisiana and Texas hubs, for example.
There's a question about other requirements under Section 45V of the Inflation Reduction Act, having to do with what the question refers to as social considerations. As I recall, in order to qualify for the entire $3 per kilogram amount, you need to meet prevailing wage and apprenticeship requirements. And the regulations around those could become extensive, and I don't think are fully developed yet. Do you have any other insight on those requirements, Brad?
Yeah, no, I don't at the moment, but I do know that the environmental criteria on the emissions is just one part, and that so-called bonus number, or whatever, they have a baseline and a top line. Those are adjusted by exactly the criteria that are identified here in terms of achieving other objectives. And I have not, this is part of the process that goes forward, is spelling out exactly how that's going to work. So it is important to recognize that those are baked in to the criteria as well.
Is there any discussion of coastal hubs that will avail hydrogen renewably produced from ocean water?
It's interesting when you look around the world, we're seeing that in places like in India, for example, they have programs that explicitly require using ocean water for hydrogen production. And obviously because there's water issues and, declining water tables and so on in India. And then I saw recently an announcement of a hub in Australia that they had succeeded in acquiring water rights for the water required for hydrogen production. So it's we're seeing a lot more explicit when you're down the pike in terms of the project development process. Securing water rights, determining what water resource you're going to use. We have not seen that yet here in the United States explicitly, and I haven't heard of it either along the coast. So, the reality is that if you can acquire water without having to desalinate it, it's a lot less expensive. So, can you desalinate it for hydrogen production? Yes, absolutely. Are they doing that around the world? Yes, absolutely. Have we seen it in the US? Nope.
Who is leading or likely to lead the effort in the Northeast region?
Well, it's actually fairly explicit. It's NYSERDA,
Right.
the New York State Energy Resource and Development Agency, as part of Governor Hochul's program. They're leading it.
And I suspect that our friends at Connecticut Center for Advanced Technology will have a hand in there somewhere.
Yeah, they're connected in. Massachusetts, the Mass CEC is the contact point for NYSERDA. CCAT is the contact point for NYSERDA in Connecticut. So it basically is like a hub and spoke kind of strategy. There are quite a number of players in that initiative.
Right.
kudos to Governor Hochul for jumping on the initiative early.
And I think that's it, Brad. Unless somebody wants to open their mic and ask a question.
Great. Unless there's anything else, we've gone beyond the time limit today, and we'd like to express our appreciation for your participation. As always, if there's anything comes up, let myself or Rick know. We encourage you to join as an individual member of the Hydrogen Energy Center, and welcome any follow-up. So, Rick, I think that's it.
I think that's it. Thanks again, Brad. Terrific job.
Thanks, everyone. Enjoy the rest of your summers.